welcome everyone to this week in Svelte episode 87. Finally back to be like the usual time. I don't know, like, do you prefer this time or do you prefer like when we do it during the morning? Because I mean, I guess if you prefer it, we can switch. But up to you. Like, let us know. Join svelte.dev/chat and let me know if you want to, like, if you prefer the morning or these hours. It's the same for me. Today we will have a community showcase, which I was talking with like the showcaser before, and like I am kind of scared because like it's about shaders and I have zero ideas about shaders. Like, I have the general idea, but I'm very excited to learn about them, and like I want to see his demos, so I'm very excited about it. Also, please let me know if I sound too high, too low, and stuff like that, because I did mess up with OBS a bit, so maybe I messed something. I messed something. I hope not. And obviously we will have the changelog and a small announcement, which actually is a big announcement that I will do after the changelog. I guess you already kind of know, but yeah, it's good to know again because I'm very excited about this announcement. Okay, let's start. I think we already did this, right? Yes, spring and tween, or maybe not. Okay, so let's start with Svelte 5.08. Again, I don't know if you noticed, but like we are in the middle of Advent of Svelte, and as I've said last week, this week is not about like this Advent of Svelte is not about challenges that you should do, but is a challenge for the Svelte team, because we are publishing a bunch of updates, one feature every day. So despite already knowing which are what features we're gonna release, I am always excited about like getting the new features like out. It's so cool, and I'm very happy that we are doing it. So let's take a look at some of those features. So we have add spring and tween classes to Svelte Motion. So spring and tween before were stores and that you can import from Svelte Motion, and you can have like nice like springy like when you change something, instead of changing immediately, it changes either with a spring movement or with a tween movement, so like interpolating between the twos. And now they are moved to classes, which is more performant, nicer, and stuff like that. So rain state missing prefers reduced motion export. This was probably a mistake, but this was another Advent of Svelte day. So we shipped media query class that you can use to actually have a media query reactive inside your application, and we also ship prefers reduced motion that you can use if you want to prevent, like, if someone is asking for no motion or reduced motion, you should probably obey to that. Always run if block code the first time. So this was a small bug fix that we had to do for the if block. Recently, the logic of the if block changed so that now if blocks actually tree shake away in your application, but there was a small bug and now it's not anymore. This is another add support for bind getters and setters. So let me actually show you svelte.dev/playground. So what this feature is about is, you know that if you have some variable, let's do state like this, you have an input, you can do bind value is equal to name, right? And basically what this does is that is instructing Svelte to do like value is equal to name, and on change, on input, name is equal to e.target.value, basically. So if I am also showing this name here, they will be in sync, because whenever this changes, it will change that. And obviously the same, like if I do change, and if I change on click, and if I change the variable programmatically, Paulo, for example, when I change, like, it changes everywhere, basically. And what we shipped is a nice little thing. Like, most of the other advent of Svelte are just very, like, QL, quality of life improvement. And the quality of life improvement in this case is that now you can also bind to a set of getters and setters. So what you can do is basically say, okay, this is the variable that you need to use to assign to value, and whenever you need to set that value, please call this function with the new value. So if I do this, this is basically just the same, right? So as you can see, like, it doesn't change the behavior. But what this allows you to do is that you can do some validation, for example. So let's say you can do if v.length is less than 10, then you set name to be name.v. So by doing this, this might incur in a problem. I don't know if, but we will see. So now when I write something, you can see that now I stop at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, if it's less than 10. So if I do equal, I can do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I cannot write anymore because I'm doing validation basically inside this. Now, this was already kind of possible before, because you could just, like, if you want, you can just do something like let obj is equal to, and you can actually use a get value, for example, and so return name and set value, so v, and you can basically do the same thing here. So if I do this, I can then bind to obj.value, and this will be the same basically. So it's not something that you couldn't do before. Like, this is basically the same. It's basically the same thing, as you can see. It works the same. The nice thing is that you can now do it inline. It's just nice. Like, personally, like, I love doing stuff inline in the template instead of having to declare something outside. So pretty nice QL. Let's go ahead. Actually, let's keep it open because we will gonna demonstrate something else for sure. Mark sub3 dynamic for bind sequence expression. So this was just a small bug with getters and setters. This thing. The conflict get name for literal class properties. So this was a small bug that we fixed because if you had a class, so if you have a class in Svelte, not in Svelte really, like test, you can have some variable like var, for example, like this. But you can also use something else, which is not an identifier. So in this case, this is an identifier. You could do something like 0 is equal to $state. And this is a slightly different because this is basically a literal type, and it's a number. And you can also do something is equal to $state. Now, what the problem was is that if you take a look at the compiled code for this, you can see that under the hood, Svelte is creating this signal, this stateful variable private, and then it's creating a getters and a setter for that specific variable. And the name of this variable is actually like, it needs to be a valid identifier. So 0 is not a valid identifier. And so what we were doing is we were just changing everything that is not inside a valid identifier to an underscore. But this meant that in some specific case, like if I had 1 is equal to state, this was not like Svelte was not able to disambiguate between the two, and so you will had like 2 times this, which is an error in JavaScript. And so now, if you see, we actually add a tiny bit of thing left. So yep, pretty nice bug fix. Allow export with source from script even if no bind is present. So this was another advent of Svelte stuff. Like now you can export let me see, I want to show you now from the module. So if I do script module, you can export a snippet. So snippet stuff, I don't know, /snippet hi, right? And from the module, I can actually do export stuff. Now, the problem is that when Acorn, which is one library that we use to like generate the abstract syntax tree for this JavaScript here, when Acorn tries to parse this, it sees that you're trying to export stuff, but there's no stuff variable in there, right? And so like Acorn says, that's no good. So to fix this, to allow you to export snippets, we had to basically hijack Acorn and say, don't worry, like if you are trying to show me this error, it's fine. I know that it will not be a problem. But we still need to prevent you to export random stuff that is not there, right? So in this case, stuff, we know that will be there. But if I do, I don't know, div, we need to warn you. We need to error out. So we actually implemented this logic ourselves, saying that div is not defined. The problem was that if you can technically do source.js and you can export const something is equal to 42, for example. And if you do this, you can technically do export from source.js. So if you do this, export something from source.js, this is perfectly valid because this something will come from source. So we don't need to warn you about it. And that was the bug, basically. So we fixed it. This is another, and we actually saw it a bit. So this is another advent of Svelte feature that now every error provides link to documentation for errors and warnings. So if we go to svelte.dev/playground again, we should probably just keep it open. Let's say that we have an error of some sort, like the script module stuff. Script module. Let's say that I do export bow. I have this error, and you can see that now below here you have svelte.dev/e/export undefined. And if you try to follow this link, what? I actually pasted the wrong thing, sorry. So if I do this and I copy all of this, now you basically have this page, which is a general like information about the error, and you can also, like in some of these, you can also get more information, like node invalid placement. What does it mean? It means that HTML restricts when certain elements can appear. In case of a violation, the browser will repair the HTML in a way that breaks Svelte, blah, 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 blah. So this is a bit more of information, and you also get these in production. So If there's some error, some runtime error or runtime warning that we are showing also in production, because most of them are actually only for dev. But if you are in production, you will get a link to the error so that like you get a better understanding of what's going on, which is nice. So yeah, this was this. Ensures snippet hoisting works in the correct scope, ensures state snapshot clones whole array correctly. So before, state.snapshot was basically, I don't know if you know about this, but basically inside JavaScript you can have an array with a hole in it. So if I do console.log array 10, for example, I don't know if this console actually show it. No, this is undefined. But if I show this console, you can see that the array, and I should probably do it again. So the array, I don't know if you can see it, and I cannot zoom in, unfortunately, but it says empty time 10, which is different from undefined. So basically, like an empty array is literally like empty. This means that if you try to map over it, you will literally skip that part. It's slightly different from undefined. And state.snapshot was basically replacing empty with undefined, but now it's not anymore. This is also another interesting bit. We saw that with input binding, you can write something like let value is equal $state, like this, and we can have input bind value. So this was not a problem before, but it is a problem now with the binding like this, because let's say that I want to, I don't know, like let's say that this is a masking input. So when there is a value, I don't know how to show it properly. Let's say that yeah, let's say that we do split and dot join on the space. I think it can work. So like this is super silly, obviously, but it's something that you might do, which is like every time you add something, like it adds a space in between. And yeah, that's really not a good example of this, but basically the point is, by default, when you set a value on an element, the browser will move the cursor to the final position. But this is very annoying if you want to do something else. And so now we actually restore the position. So you can do AB5 and we will restore the position. Yeah, this is not the right example to this. Maybe I should do it here rather than there. Maybe. Yeah, it's not a good example, sorry, but I cannot think about one. But the idea, like the thing that I wanted to show is that now the position is restored to where it was before, which is nicer when you have to do some masking and stuff like that. So this is something about transform of the global. So if you know, you can do on the CSS, you can actually have a global block now, and everything nested inside will, like the selectors will be global, but if you are using, for example, some keyframe, you still want that to be transformed, and so that was it basically. Overwrite spring last value when using set with instant true. So this was a small bug that if you are using the spring class and using instant true, which basically means, okay, update this immediately, don't worry about the spring value. It was causing a problem. This was actually a new contributor, which it's super cool. You should contribute to Svelte. Fix don't emit assignment warnings for bindings. Take into account registration state when setting custom element props. So this is another small thing about custom elements, is the fact that like they always create problems. And now we also have another feature from Advent of Svelte, which is Svelte reactivity window. So now you can actually import from Svelte reactivity window like this. And what this does is that this allows you to import something like inner width, for example. And this is a reactive value, and you can use it like this: inner width dot current. So right now is 633, and if I move it, you can see that it changes, which is pretty cool. So to do this, you basically before had to do something like Svelte window bind inner width to some variable, but now you can just import it from here, and that's the power of runes. Let's go ahead. Account for global blocking is empty. Remove over the, so we had this warning for a while, but this was firing way too often, so we actually removed it. There was some problem with SSR with reactivity window. Avoid mutation validation for invalid inner signals. Make default value work with spread. This was another feature of Advent of Svelte. Handle iteration of script style elements. So this was if you were using something like a Svelte element with a script or a style, it was not iterating correctly, and now it is. Sorry guys. Allow unquoted slash in attributes. This was actually, so don't ever do this in my opinion, but basically like if you want, you can do something like a tref is equal, and instead of writing like this, I don't know, slash good, for example. So instead of writing like this, you can write something like this. Good, I don't know. But technically, you can also write it like this without quotes. I don't know why you should do this. Personally, I would suggest you don't do it. Also because very likely we will deprecate this in Svelte 6, but now you can also use trailing slash for this. And before it was erroring out because it thought it was the closing of this this thing. But yeah, you can do it. Don't. Okay, this was another small bug, like the media query class automatically added parentheses for you, but it's not actually needed because not that it's not needed. Sometimes it can cause problems, so to fix that we now check if you already have parentheses inside. And expose more AST types from Svelte compiler. This was a very cool PR from a member of the storybook team, and they are working on Svelte print, which is a utility to like print a Svelte AST, which is missing and is very cool, and it needed more types. So he opened a PR. Let's see Svelte Kit. We have some new release. Correctly match root group preceding optional parameter. Prevent hooks exported from hooks.js from overwriting hooks from hooks.server.js. This is something that was happening, now it's not anymore. And now we have a new hook, the init hook. You can use this hook basically to, in Svelte Kit, this is another Advent of Svelte feature, and you can basically use this whenever you don't have top level await to like this will be called by Svelte Kit. The first thing that Svelte Kit does, it will be called once in the whole Svelte like application lifecycle on the server, and obviously once on the client. But on the client, every time you refresh the page, it will actually be called because like it's a new Svelte Kit client app. So, but you can basically use it to initialize stuff in your Svelte Kit application. Sometimes, like especially in Safari, you don't actually have top level await, and that can cause problem with bundlers. So instead of using top level await, you can actually just use the init hook as of 4 days ago. It's very nice because like this was merged, but it was not exported, so we had to publish another release for that. Correctly resolve hooks file with a similar name the directory exists. So before this was a bug because if you had hooks.js and a folder named hooks, the folder will have precedence over the file. But now it only have precedence if you have an index.js inside. This is another cool feature because basically now you may know that you cannot export everything from a plus page.server.ts. You cannot export everything. Before, it has to be a POJO, basically, like a plain old JavaScript object. But now you can actually export classes as long as you provide a transport. So on the hooks.js, you can provide a transport variable and you can specify, okay, when Svelte Kit encounters this class, serialize it using this and deserializing using this, which is pretty cool. Adhere to vit build minify settings when building the service worker. Pretty nice. Let's skip over the other because there was some release, but I'm very eager to hear from our friend. But before, a brand new announcement because a brand new Svelte Summit website just landed, and it's Svelte Summit Spring 2025. And the very nice thing is that you can see that it has a location. It will be a live one. So finally, we will meet again. So we are waiting for you at Barcelona, May 8 and 9 of 2025. Like, sign the date because Svelte Summit will be live. You can buy ticket. Please submit a talk. We are eager to hear from you. And if you want to buy ticket now, you also have this discount code that is valid until the December 31. And if you want some group ticket, you can also invoice this. Obviously, if you want to become a sponsor, if you want, like, these are some thing, like this will be the venue, which looks super cool. I cannot wait to be there, even though it will be my wedding anniversary, but I will bring my wife and my kid. And I'm also very, very excited because like with my company, we are actually helping around, so we will co-organize the thing. I'm very happy that we were able to do something together. Very cool, and I cannot wait to meet you all, and please come, and this will be very, very cool. So that's it. Let's switch to something which is much more interesting for you probably, because now let's switch to the community showcase. So let me just check if our guest is ready. Okay, it is ready. So let's switch to this view. And I also, like, first thing first, I hope that you don't hear me twice. I removed my microphone from here. How should I call you? I forgot to ask you. So
Yeah, my name is Holger. I don't know if
Okay.
it might be a bit hard to pronounce. Uh,
Yeah,
yeah,
it maybe, but for me, Helga is good.
yes, that's great.
Okay, great.
Yeah,
So I will
yes,
leave the stage for
but
you, and I will leave the stage for you, and feel free to, um, yeah, feel free to present your work.
thanks. Yeah, I'm here to
I'm trying
present
to
the
leave. Sorry.
Svader
I,
library, which I've made.
oh, I can. I
Yeah.
can. I don't know what to leave.
Yeah.
Okay.
Okay. Right. Okay. So I'm here to present the Svader library, which I made to basically render uh, shaders on the web. And when I say shaders here, what I specifically mean are like two-dimensional fragment shaders. Basically, instead of using something like the Canvas API, instead using a um, shader to draw shapes. I'm not going to be talking about any three-dimensional stuff that you can also do with it. Not with Svader. Svader is made specifically for 2D. Um, I mean, you can draw 3D like you always can, but there are no 3D objects or anything. It's just a 2D canvas, and that's what we're talking about. So anytime I say shader, kind of like substitute that for, you know, 2D fragment shader art, the kind of stuff you'd see on Shader Toy. Okay, so I'm going to be going over first why I think you like should be using shaders on the web, or why you can use that um, more than it's used today. And then I'm going to be giving a little demonstration of implementing a shader with the Svader library. Okay, so as to why you'd want to use shaders on the web, I believe if I were to ask the majority of web developers what tools they would go to for rendering custom graphics on the web, they would probably say these three things. First of all, they have raster images or videos. These are your normal PNG, JPEG, MP4s, straightforward. Then you have SVG, vector graphics, and then you have your JavaScript Canvas, 2D Canvas API. I'd like to advocate a bit for adding shaders to your tool belt. So yeah, you can maybe use that the next time you're standing in the situation of having to generate some graphics. Okay, so if you look at these regular raster images or videos, they have the strengths that they're pretty straightforward. It's just a single HTML tag. They don't require JavaScript to render. They can render fine in like all environments. And yeah, I've written that they can contain anything, which means like in contrast to vector graphics or something like that, you could either have a flat illustration or a photograph or anything in between. But they have some cons, which are that they're heavy. Like if you have a page with images and videos, they're most likely going to be the majority of data sent over the network. So you'll often have to use some sort of lossy compression, which means that you might lose some smaller details, especially with video. Uh, you don't get perfect results, right? And they don't scale, like vector graphics do. Uh, yeah, at least not on the client, right? You can do some clever stuff with uh, you know your servers and loading dynamically, but right now we're talking about on the client, they don't scale, neither in terms of resolution or in terms of frame rate. And high refresh rate monitors are getting more and more common these days. And also, as a generalization of that, they're not dynamic. You can't, like, on the client, um, change them in response to user input or some sort of data or whatever. Uh, at least not without being very clever. Um, then you have SVG, vector graphics. Again, they can be pretty straightforward. They don't require any JavaScript. Again, just a HTML tag. But they have the pro of having this automatic scaling, and they can be dynamic. You can change them with your JavaScript. But cons, they're limited to vector graphics, and written they may be slow, especially if you have an animation or something like that with a lot of elements. Especially on phones and stuff like that, where they might slow your app down, make it less responsive. Then you have Canvas, has the pro of being like dynamic by default. You've already written your render function once. You just need to call it again with different data or whatever, and you can react in that way. They can be scaled. They're not as automatic as vector graphics, admittedly, but it is possible to scale them up and down in resolution and frame rate. And third of all, they're pretty lightweight, at least compared to like sending an entire raster image. Sending just the JavaScript code to generate that is almost always going to be lighter. Cons, of course, it needs JS. It can't be rendered like on the server, or right, it isn't rendered on the server. And again, it has some limited content because even though it is raster, I've rarely seen them used for anything more than you could also have done with vector graphics, right? It's lines and curves and figures. Again, they may be slow if you're doing animations of large canvases with a lot of elements. It just takes a lot of processing power. Okay, so as the new thing, shaders, I'm assuming that most people aren't out there writing shaders like on the daily. Um, they have the pros that they're dynamic by default, like the canvas, and they can be scaled. And again, they are more lightweight than shipping over an entire video or entire raster image. And I've added they can have more depth and texture. And I've brought this image as sort of like an example. I don't know how well it's translating in the stream, but if you look closely at this, it has like some film grain here um, in the darker parts, and right, you have some light source here that's shining out, and some depth here that would just not be to or not practical to do in a canvas or vector graphics, for example. And I've written as a plus performance. They are generally very, very performant. Um, yeah, out of the box. Of course, I'm not trying to sell anything. They obviously also have the con of needing JS and the con of actually needing to learn shader programming. I have the impression that a lot of people kind of like have this idea that it is somehow some sort of weird mind-bending magic. It's not. I mean, it's a different paradigm that you have to wrap your head around, but it can be done in a weekend if you have some time. And also, when I show the demo, I hope to show that it might not be as mind-bending as you might have imagined. Yeah, and I've made a lot of claims about performance, so I've just brought a little example. of some performance. This is a stress test. It's meant to be a stress test. I'm not claiming this is like a realistic, benchmark. It's just pushing it to its boundaries, right? So what I've set up is this huge 10,000 by 10,000 pixel canvas containing 10,000 of these um, orbiting circles, and it's animating, right? So it's really not realistic, but it's an example to show the scale of performance we're talking about. So if we start with the SVG, you may or may not be able to tell that this is really struggling. You can check here, it's getting 4 to 5 FPS on this machine. And right, this is my desktop. I don't want to even think about, my mobile. Okay, then we can check the canvas implementation. And same story, it's really struggling. Even more actually. Yeah, it's just getting 2 FPS. Not great. And this is, of course, a consequence of the fact that this is implemented as literally just a JavaScript for loop, looping 10,000 times and drawing these 2 circles for each time. Yeah, so that's a lot of loop iterations. But again, if we look at the shader, it's running completely smooth. If we turn on the FPS, it's actually saying like around 144 frames per second, which is what my monitor maxes out at. So it's having no problem. Okay. So as a part 2, kind of like why would you use Svader then if this is just built into the web platform? Svader is a library with Svelte 4 and Svelte 5 support. It's built for Svelte. It handles the boilerplate for you. It's about 100 lines of code to set up this whole rendering process of rendering onto a canvas like this. It's not enough to weigh down on your bundle, but it is enough that it's annoying to deal with. Setting up a bunch of vertex buffers and stuff like this. Svader, it has some nice quality of life features. It supports infinite canvas size because by default the canvas size is capped to something like 4,000 by 4,000 pixels, which is large. But if you want to do something larger, like landing page where it covers the whole page, including the scroll area, Svelte just handles that for you. Make sure it creates a cutout that always covers your screen. Yeah, it does automatic scaling, not entirely automatic, but by default it scales your canvas to match the actual physical pixel pixel density of your screen. Yeah, you still have to do a little bit of work to scale what you're actually rendering, but by default you're encouraged to do so. Then it has some built-in parameter values. For example, you almost always want to path the resolution of your canvas into your shader program. That's just a flag that you have to set in Svader. Also, it has support for both WebGL and WebGPU. If you don't know, WebGPU is the new kind of experimental standard. Yeah, so use WebGL by default, but you can use this if there are some features you want from WebGPU. Okay. Now I'd like to move on to giving a little demo. And I'll try to be quick, relatively quick. Yeah, so what I want to create for you today is this kind of demo where you see we have this bowl and it kind of like responds to when I move my mouse cursor, it expands and it has this glow to it. Okay. Yes. So let's just remove, start over. So we have a blank page here. We have like a blank Svelte Kit page. And the first thing we'd like to do is just to set up. Uh, this is not meant to be best standards at all. Like, what do you call it? Uh, Best practice. I'm just making sure we fill out the whole thing. And okay, so now we can actually fill the whole screen. Okay. So now the first thing we'd like to do is just create, just import our, I'm going to use WebGL, or WebGL shader from Svader, and then create this WebGL shader component. Okay. When we create our WebGL shader, it needs two things. It needs the code, the shader code, and it needs some parameters. Let's just make it empty right now. And we don't have any code here, so well, what we can do is we have this .frag file out here. That is a shader code in GLSL, the shading language. Since we're in Svelte Kit, we can just import code from use this raw import. Such that now we're just importing the string contents of this file into the code variable, and now we're just passing this string into this component. Okay, but yeah, we're not done because we have nothing in here, right? But actually, I think I'd like to start with doing the logic that we need to have out here, because we need to pass a parameter into this, obviously. And right, what we saw in the demo was that it was the speed of our mouse cursor. So let's say mouse speed equal to state 0. And yeah, we'll just define this logic out here, handle mouse move. Okay. So we'll obviously want to have our pre-mouse position, and that will be like an XY coordinate or null, because we're starting out as null because we don't have any previous. So let's say if it's not null, then we can just destructure it. Okay, and then we need to calculate this, and if you remember from your math class, that's this. This is the current x minus the previous x to the power of 2 plus the same thing for the y, and then the square root of that. Okay. Then we're going to set this to the current position. Okay, and then we are just going to use the Svelte window to get this on mouse move. Okay, so now we actually already have all the data that we need from out here. And now we'd like to pass this into here. Yeah, so let's quickly move over to the shader first to define what we're actually expecting. And well, we can start with some the boilerplate. We declare that we're using version 3.0 of this WebGL GLES language. We have medium precision floats. It doesn't really matter. I'm just going to use medium precision. And then we have our output variable, which is vec4 of frag color. This just tells the shader that we're going to be putting the final color of the current pixel into this variable. And it's a vec4 vector with 4 entries because it's R, G, B, and then alpha. Okay. Then we'd like to decide what we actually need of input, and I'm going to cheat a bit because, yeah, I've done this before, so I know we need, so uniform means like it's an input, and this is a vector 2, which is called u underscore resolution. This u underscore, it's just a convention. You don't have to name it that. This is just the names that we're defining. So I've said we need resolution, which is like the size of our canvas, an offset, which is, if you remember, I talked about how you sometimes do like a virtual canvas that's larger than the real canvas because the size is too big. This offset just, right, we're not going to need it right now, but it's just best practice to just keep it in because that means even if we were to size our canvas ridiculously large, it would still work. Okay, and then I've just called this data, which is what we pass in, which was our mouse movement. And I've just said that's a floating point number. Okay. Yeah, so now that we've defined this, we can go back here and pass it in because this is what our parameters are. It corresponds to these uniforms. So yeah, so we need one called uResolution. And for the value, these are one of these built-in parameters that I talked about before. So we can just set this to resolution, this string, which is a built-in value. Right? So it already knows what resolution is, and it'll feed that vector 2 into it. Okay. Then we needed offset. Again, that's also a built-in value. And then we just call it data. It's a bit like, it's not a very descriptive name, but it's just to exemplify like some data that you could pass in. And for this should be our mouse speed. And now that it's not a built-in value, we actually need to tell it the type of this, and this was float, right? Because you might want to pass this in as an integer, but we want to do it as a float. Okay. So this basically concludes everything we need to do out here. We're calculating the value that we want to pass in. We are, setting up our canvas and passing in these actual values. So the rest that's left to do is just implement this shader. Okay, so I'm going to be showing just quickly an overview of how you'd write the shader. The goal isn't to teach you 100% how to write shaders. It's because that's beyond the scope, but it's just to give you an idea of what it looks like. If you can follow it 100%, that's great, but I don't expect you to. So, right. Um, the first thing we'd like to do, right, by the way, I'm writing this main function. The main function is the entry point, just like in C. So the first thing we'd like to do is get our actual position on the screen. That's just stored in this global value frag chord and .xy, because for some reason this is like 4-dimensional. I actually don't exactly know why. There's some depth to it, and it's kind of like, yeah, but we just care about the x and y. And then for good practice, we use this offset and add it to it. Then it'll always work. Yeah, okay. So what we would like to do, if you remember, is that we'd like to do a circle. And I'm declaring the circle as a float because remember, right now we have to like view this from the perspective of a single pixel. And from the perspective of the single pixel, a shape is just, it's just somewhere from 0 to 1 about how much of this shape is on this pixel. Okay, and now I'm just imagining this function that I'd like to have that I haven't declared yet, of draw circle. And it takes these parameters. I think is reasonable to give it the position that we are in the screen, the radius of the circle, and the center of the circle. Okay. And what should we already have the position, right? What should the radius be? Well, it should be a float, first of all. And I found that, right, we wanted to increase the more we move our mouse. So we want it to be the data. And then I found just scaling it to 5.0, it looks the best. As for the center, that's coordinates, so that's a 2-dimensional vector. And that is just the center of the screen. So you can actually write this, which is shorthand for dividing the x coordinate of this by 2 and dividing the y coordinate of this by 2. So that's kind of cool that you can do the shorthand. Yeah. So when we have this circle, I'd like to take a frag color and say that that should be equal to this circle value times the color that we like it to be, right? Because the circle, it's 1 if we're inside the shape, it's 0 if we're outside the shape, and it might be like somewhere in between if we're like at a fuzzy edge of it. And what this does is basically it takes this color. You can use this color picker, by the way, and it displays it at this pixel with this opacity. Okay. I know I'm going over that a bit quick, but I think you can look it up if you'd like to know more about why that is. Okay, so let's try actually implementing this draw circle. Okay, so it had vec2 position for radius and a vec2 center. Okay, to draw the circle, we are going to be doing this distance trick of taking the distance in pixels from the position to the center. And now if we say that our circle is equal to step 100 dist, and we return our circle. Let's see if it works. Yep. So you can see, first of all, it's inverted, but we do have our circle here. And also it doesn't look that great. It's a bit jagged around the edges. Yeah, but we have a circle, and that's because you are, well, what this step function is doing, right, this right here, it is basically taking this value, our input, our x, which is our distance, and then it has some point 100. We're just hard coding it to 100 here. Then if it's below 100, then the output is 0. If it's above 100, the output is 1. Right? It just snaps hard. And that makes it look like this because in here the distance to the center is less than 100, and here it's greater than 100. Now, first of all, we can realize that this right here is actually kind of like the outside of the circle. So to flip that, we do this. And now we actually have the circle here. It still doesn't look that great. I don't know if you can see on the video, but it has like very sharp edges, and you can see like the pixels where it's like jagged. So what we can do is we'll use smooth step instead and say, let's try saying 95 and 100 and dist. What we will get is a fuzzy circle. I don't know how well you can see it on the video. If I set something even crazier, right, now you can see it's kind of like it's a blurry circle. And the reason for this is because what the smooth step does is that it takes two values instead, and then it snaps to 0 if it's below the lowest value. It snaps to 1 if it's above the highest value, and then it interpolates between them, and then we get this fuzzy effect, right? So we can actually use that if we don't want it to be super jagged, and if we set this to 99, we'll actually get a kind of nice looking circle. Yeah, so of course we didn't want this to be 100, we wanted this to be radius, and let's just say radius minus 1. And now we actually have this circle that expands when we move our cursor fast, but it doesn't look good, right? It's way too like jittery. So I think this is actually great potential to go back into a Svelte and use some magic on this number, right? That instead of just setting it to a state, we could use this spring from that was Svelte motion, right? We can say new spring target, and then we pass in the dot current, right? Yeah, and before I just found it looks a little better if you set the stiffness to 0.05, I think. Yeah, so now we get this where it's like it's much more smooth. So it's just an example of you can actually use your JavaScript to and your Svelte to kind of like yeah it fits very nicely together by basically using it to like pre-process your values like that. Okay, but I also promised that we would make it glow. Um, and we can do that just really quickly by saying like 4, so it's a RGBA color kind of, and saying found like u data times, no, sorry, divided by 50, and then we wanted it to glow kind of like yellow. So yellow is, uh, you know, full red, full green, no blue, and I'm gonna set the alpha channel here to be 0 as well, because now we can just add this, and what this does is that it adds this like entry-wise. So it adds, uh, right, this multiplied by some value of data, and this multiplied by data. It adds that to this, so it basically like saturates these two channels, which makes it brighter and more yellow. So if we check this out, it it grows larger and it gets yellow. Yeah. So that's it for the demo. Yeah. So I just like to encourage you to kind of like play with this and try using Svader.
Sorry, I'm back. I just trying to set my where it is video source. Here it is. I am back. Oh boy, this was very cool. Like, I think it's. Can you hear me? First thing first.
Yes. Yes.
And like also from the chat, if you can hear me. So first thing first, like very cool demo. First thing first, and in general, I think it really shows like it seems very easy to use. Like it's a library that seems very easy to use. Like I love that you were getting a bunch of errors for TypeScript, because this really shows that it was like built with TypeScript in mind, in my opinion. And that's obviously like very interesting. And even the code for like, obviously this is just to draw a circle, but it's cool in my opinion. Like it's something that really intrigues me. I never actually looked at how to write a shader, but it's very cool, and I can imagine the kind of stuff that you can do. I think that the thing that really like will be probably difficult for me is thinking in the like with the perspective of a single pixel. I think that
Yeah.
that's the most important, like I think that's the most difficult part. But I think like this seems pretty seamless, like the integration between like how to pass values between your library and the fragment is pretty cool. Congrats.
Yeah.
I think it's very
Thank
interesting.
you. Yeah. Yes. So a point I wanted to get across here was also like, um, that you hear oftentimes that to write a shader, you need to learn an entirely new language, which you do because this is not JavaScript. But I hope I've shown that it's not that
Yeah,
different to JavaScript. The language itself isn't the hard part, right?
yeah, I agree.
There are very few, maybe besides the smooth step function, right? There are very few things here that you wouldn't also have in JavaScript.
Yeah,
The main issue is, right, the shift in paradigm of thinking, from the perspective of a single pixel.
yeah,
And yeah, of course, we have the book of shaders. Um, it's really great uh, if you want to dig into this.
yeah. It's pretty cool. And again, I think um, there's also like some pretty nice stuff into this language. I don't know which language it is. Like first thing first, I also think that like at the moment you know a language, especially if it's a C-like language, just like JavaScript, it's very easy to switch between languages. Like you might not know the syntax very well, but this day it's very easy to find a syntax, and you may not know all the functions and like all the standard library of the thing, but you can pretty much just search on Google for that. So I think it's very nice. And also again, like this language has some pretty cool stuff, like the fact that you can just like multiply a vector and it does vector multiplication, vector addition. Obviously, like it has been built for this stuff, so that's why it's so easy, but it's very nice. And I love the VS Code integration that you can actually use the ditch picker on a vec4. So pretty
Yeah.
nice. I think there was a
By the
question.
way, I
Yes, please.
so I wanted to give a shout out to these people, Pocket Shader. They're actually also um, in the Discord for Svelte. Um, yeah, because that's just it's very similar. I found out about after I made Svader. I found out that they've made also a version that works for vanilla JavaScript,
Mhm.
um, which is also very cool.
Yeah,
So if you're not using Svelte, you can use that.
yeah, yeah, pretty cool. And by the way, like again, like I also love that you can actually use Svelte to drive the interactivity of a shader, which is very very nice. I think we have one question, which is what about passing in vertex shaders? And what's the difference between vertex and fragment shaders?
Yeah. So um, yeah. So the the answer to the first question, how to pass in fragment shaders, you can't. Right. This is strictly for fragment shaders. Um, yeah. So the difference is that yeah, fragment shaders is what I've shown here. It is uh, a shader that is executed for every single fragment, which means pixel on the screen. Whereas vertex shaders, they are, if you have like a 3D mesh, then a 3D mesh, it consists of vertices and triangles, with vertices being like the edges of the triangles, not the edges, but the points of the triangles, right? So you have vertex shaders that manipulate those in some sort of way when you have 3D objects, and then you have fragment shaders, which typically goes afterwards of um, yeah shading each single pixel. So this is just for doing the second.
Yeah, gotcha. Just out of curiosity, and I don't know if like it's a question that actually makes sense, but like, do you think this could be also applicable to something like Trelt or like libraries for like 3D stuff, and like I don't know, use your library to apply some like texture on an object, or I don't know, it's just a random idea, and I don't know if they are. I know that shaders generally are used for 3D stuff too, so I don't know if like, do you think your library could also be used in conjunction with Trelt?
Well, Thread that's built on like 3JS, right?
Yes.
Yeah, I believe 3JS they already have this.
Okay.
Like they have this whole thing set up that, right? Because you have your rendering pipeline. When you do 3D stuff, you you start by running the vertex shaders and doing all the 3D stuff, and then afterwards you do the shading. And uh, Svelte, if it is uh, compatible with 3JS, then I'm pretty sure it already has that
Yeah. Yeah.
built in.
Okay, I
So,
understand.
yeah, so
Okay.
this is more of the specialized use case of just 2D. You
Yeah.
just want to render 2D.
but it's still pretty cool. So thank you very much for showing up. Thank you for showing us your work and your library. Like, can you drop a link in chat for your library, because I guess people want to take a look.
Um,
uh,
I
I think
think it's already in the description.
yes, it's already in the description. You can also find it in the description. It was just for the
Mm.
live person, but it's fine. You can also find the link in the description. Thank you very much,
Yeah,
and I'll see you in the Discord.
yeah.
Okay, guys, thank you. And like, that's a bit of a mess behind me, like you see different stuff, but thank you very much. Thank you for showing up, and I think that's it for today. Thanks for staying that long. It was like a long community showcase, but it was absolutely fantastic. uh, I hope you learned something. I hope you enjoyed it, and I'll see you guys next week. Bye.